Good afternoon, students. My name is Rakesh here, and I'm the faculty of mathematics. So here in this session, today we will discuss some important stuff in maths. Actually, in this, we have a very short session this time, so we don't take the complete session right now. So I will just make you comfortable in this session. That's why I wanted to know that, IIT Advance is not a kind of, people make it a hype. So it is not a hype. So I will illustrate with some examples today. Okay. So questions are very basic generic in nature. You have to go in depth and understand the nitty and gritty of this. So here in this session, actually what we will do, like we will take some questions and especially asked in IIT Advance, and we will explain them. I will tell you how it is so easy, how it can make you comfortable. I'm not saying that all the questions are easy. Yes, some questions are quite difficult, but at the same time, you have to give your approach. So your approach is very important, like how you actually try the question. That is very important. So let's talk about one question that was asked in 2022 in IIT Advance, and it was asked in JEE-Advance, and it is related to theory of equation. So I will write the question first here. So the question is if A comma B denote the distinct real roots of the quadratic polynomial x square plus 20x minus 2020, and let C comma D denote the distinct complex root of the quadratic polynomial x square minus 20x plus 2020. Find the value of AC within bracket A minus C plus AD within bracket A minus D plus B within bracket B minus C plus B minus C plus BD within bracket B minus D. Okay, so this question is quite lengthy, but if you try to understand, this is very easy question, and it was asked in advance to 2020. So the question, what is saying? It's all about quadratic equation. That's you must be aware since your 10th grade. So actually the question is like there is a quadratic polynomial, and it has two roots, real roots. We have, and you see the uniqueness of this question. It is asked in 2020, and even the quadratic, you see the this term is 2020. And here again, x square minus 20x plus 2020, it has again two roots. And here the two roots are complex roots. So you don't have to worry at all about the roots. The thing is that the basic that we know, like sum of the roots and the product of roots, we will simply get it and put the values here, you'll get the answer. So let us see in the next slide. So the very first thing is x square, and you have here plus 20x minus 2020. Okay, So a and b, a comma b are the real roots of this polynomial. So what would be a plus b? That is sum of the roots minus b over a, so minus 20. And what is the product of the roots? That is c upon a, that is minus 20, 20. Now again, x square minus 20x plus 20, 20. Here in this, you will see you have two roots, c comma d. So sum of the roots you will have is c plus d, that is 20, and product of the roots is, that is c upon a, that is 20, 20. Okay. So now what do we have to do? We have to do nothing. We have to just put the values here. So what do we have to find? We have to find here AC within bracket a minus c plus AD within bracket a minus d plus BC times within bracket b minus c plus BD within bracket b minus d. Okay, so now in this, what will you do? First of all, the very first step that we can do that comes to our mind is we will open the bracket. So if you open the bracket, what will it happen? Like a square c minus ac square plus a square d minus ad square plus b square c plus minus bc square plus b square d minus bd square. Now, what would be the next step? Next step is, now here c, a square c and a square d. What can be taken common here? A square. So you will get a square and within bracket c plus d. And this one and this one. What is common here? You see a is common. So we can take minus a common. So it would be c square plus d square. And then again here b square c and b square d. So b square is taken common. So b square is taken common. So c plus d. And finally the last one and this one, bc square minus b square minus bd square. So you can take minus b common. So it would be c square plus d square. Okay. So what do we observe here? We can see here that c plus d and here c plus d, that is common, and c square d and c square plus d square, that is common. So we can take it here. So what we can do in the next step, that c plus d is taken common, c plus d is taken common. So you will have a square here, a square plus b square. So it would be a square plus b square. And if you take c square plus d square common, then you have to take it common minus. So minus c square plus d square. And within bracket you will have a plus b, because minus is already taken common. So here in this case, and in this case, it will be a plus b. And now see the values. We are already a plus b and c plus d is given. So we are already given the values of a plus c and a plus b and c plus d. Now what the next step will be? Next step would be, let the c plus d as it is here, and a square plus b square can be written as a plus b whole square and minus twice ab. Minus, in case of c square plus d square, what we can write? C plus d whole square and minus 2 times of cd, and finally a plus b times. Okay. Now we just need to put the values and you will get the answer. So here you see in the next slide. So what was the previous slide? Here we have is c plus d. So what is the value of c plus d? 20. So we will write here 20, and then within bracket you see here a square plus b square So a plus b whole square, a plus b is minus 20. So we just need to put the values, or apart from this, what we can do, we can rub some of the portions. All right. Let's go. It is this one, right? Okay, so let me just erase this portion first. Okay. Okay, now let's see, just put the values here. We have C plus D. So C plus D is nothing but 20. And within bracket, A plus B whole square. So A plus B is nothing but here minus 20. So minus 20 whole square. And minus 20 to AB. So 2AB minus 20. So 2 times minus 20. And then again minus and C plus D. So C plus D is 20, so 20 square, and minus 2 times CD. So CD is 20. So 2 times of 20, and here A plus B, that is minus 20. So here we put it minus 20. And in this case, minus 20 square we have taken C plus D, and twice AB. Twice AB is 20. So here it is 20. Okay. So now the next step would be simply like 20, and this is a 400 minus plus 4040, and then minus within bracket 400 minus, and here it is 4040, and negative 20 and negative 20 makes plus 20 here. Right. So next step would be, if you take common entirely 20, so what will you find? 400 plus 4040 plus 400, and here it's 4040. So it is this 40 and 40 will get cancelled. You are left with 800. So it is 20 times 800. So this will be 16 and 3 zeros. So this is the 16,000. This is the answer. So I don't think there is any problem in this question. This question was quite easy and it was asked in IIT Advance. So now moving to the next question, I will take one question from integrals. The basic integral, and this integral you see is equal to pi by 4 1 minus sine x over cos x, and here it is tan inverse dx. So you have to find the integral of tan inverse 1 minus sine x over 1 cos x. So what is important here, if you apply the integral of tan inverse, so it will be quite lengthy, right? And it's not advisable. I am actually trying to tell you the blend of trigonometry and calculus being asked in this question. So if we go with the traditional method, of course, it will take a lot of time. So what is the best part? The best part is, if it is possible, we can convert this 1 minus sine x over cos x in terms of tan x, if it is possible. And if it is possible, then tan inverse and tan will get cancelled, and we will have very simple integral to find. So the entire crux of this question is to simplify this part. So how will you simplify it? So 1 minus sine x over cos x. So we know 1 can be written as sine square x plus cos square x. So in place of 1, we can write sine square x over 2 plus cos square x over 2. Why we are taking this? The reason is, here it is sine x. So sine x, it's a sine 2x is to sine x cos x. So it would be negative minus 2 sine x by 2 cos x by 2. Okay, so we can take this, and cos x can be written as cos 2x. Cos 2x means cos 2 times in x over 2. Right, so cos 2x, we know cos square x minus sine square x. So it would be cos square x over 2 minus sine square x over 2. So the next step will be, in the top, what will you get? Like a minus b whole square. So cos x over 2 minus sine x over 2, and entire thing whole square. And in the denominator, what will we take? A square minus b square is a plus b into a minus b. So it would be cos x over 2 plus sine x over 2 times cos x over 2 minus sine x over 2. And here this square and this can get cancelled. So you are left with cos x over 2 minus sine x over 2 over cos x over 2 plus sine x over 2. Now in this question, we are very close to the tan, because if you divide both numerator and denominator with cos x over 2, then you will get cos x by 2, cos x will get cancelled, and you are left with here. Here what will you get is, you will simply get, if you divide it, so you will get it here, 1 minus tan x over 2 over 1 plus tan x over 2. You simply need to divide numerator and denominator with cos x over 2. Okay, so here what we can write, 1 can be written as tan pi by 4 and minus tan x over 2 upon, and here 1 plus tan pi by 4 times tan x over 2. So here tan a minus tan b upon 1 plus tan a tan b, and this will be nothing but, here it would be tan pi by 4 minus x over 2. Okay, so entire result, whatever we got here, this much is in the terms of, we can say that this part is completely transformed into tan pi by 4 minus x over 2. Okay, so why we did all these steps? But just because this tan and tan inverse will get cancelled, and we are left with simply, without any trigonometrical ratios, we have a 0 to pi by 4, and here pi by 4 minus x over 2. So it's quite simple to integrate. This integration is nothing but pi by 4 x minus x square by 2, and then again 2, so x square over 4, and this would be 0 to pi by 4. So if you put 0, you will get both parts 0, so it's just put pi by 4. So it would be, x is pi by 4, so pi by 4 times pi by 4, it's a pi square over 16, and minus, here we'll get pi square by 16 and 16 and again 4, so 64. So this is the answer. So what actually I'm trying to do in this question is, first of all, I'm making you aware that you cannot jump to the conclusion that it's a calculus, so you have to do all the applications of calculus only. Firstly, try to understand whether it could be solved in other way around also or not. Like in this case, what we did, we have actually converted this 1 minus sin x over cos x in terms of tan x. So this tan and tan inverse got cancelled, and we are left with only this portion where it's no trigonometrical ratios. It's quite easy to integrate this. So sometimes integration is quite difficult to integrate. So this is the way we can do it. So that's it for the day. Thank you, all of you. Thank you very much.